Welcome to Alchemical Science. I am Jordan, a self-taught farmer, physicist, and electrical engineer who conducts open source research in the fields of unified physics, radiant power systems, neuroscience, and the energy systems of plants, soil, and the human body. No new ideas that come up in my videos can be patented. In this video, I wanted to talk about how air, carbon, and water all can store matter, information, and energy. And it's really just a little kind of introduction or posing a few questions about the topic. Because obviously these are really well explored things and there's a lot of modern scientific data on them, but I'm exploring them from a more kind of universal perspective, how they fit in with unified physics and how we can kind of, rather than just endlessly analyzing deeper and deeper into, the chemical constituents and what's happening chemically between these things, looking at the energetic science of it, how these, carbon, water, and air all have their own capacitance and can all store information, energy, and matter in a few different ways. So just here I've got some ground caraway seed, and it's been soaking in alcohol for about 2 or 3 weeks. I'm making a tincture out of it, but with alchemical spagyric tinctures, you don't just throw away the plant matter after you've done soaking it in alcohol to try and draw out those constituents. You actually go through a further process with the ashes of the plant. You recombine them to make elixirs and tinctures. And there is some reasoning behind this. A lot of this came from the work of Paracelsus. And he claimed that, there was 3 constituents to everything: the salt, the sulfur, and the mercury. And these are kind of really broad, esoteric terms that can describe a lot of things. But essentially, the mercury was the alcohol or the solvent or this kind of liquid that was filled with the energy and had some imprint of a plant or potentially animal remains or minerals or metals as well, because alchemy is quite broad. It's not just to do with plants. And then you also had the salts, which was kind of the physical matter, the womb or the matrix where the more volatile elements of the plant were nurtured and grew. And then you had the sulfur, which, is kind of synonymous with the soul, being the more volatile oils and the real essence and character of a plant. And so he talked about combining these 3 things to make superior medicines, which of course I'm not claiming. This is just historical information that I find interesting. But what I do find interesting and that we can relate to proven science is that, for example, if we have these white crystal foods, and again, broadly speaking, but things like sugar, things like salt, when we put these in our mouth, as opposed to sugar being this refined, very kind of volatile carbohydrate, as opposed to regular carbohydrates, if we're just eating, fruits or vegetables or grains or something like this that are going to slowly release energy to us. Sugar will give us this immediate energy hit. You can find it in the blood immediately, you get this shaky high. And interestingly enough, these white salts are what Paracelsus said when used in medicine, and I mean white salts more broadly, so not just sugars, but any kind of refined carbohydrates that we've burned down or refined through a process, whether it's sugars or ash remains or anything that will form this kind of white salt crystal, will signal to your mouth, to your digestive system, that what you're intaking is already digested or ready to kind of act immediately on the body's systems. So I find that kind of correlation really interesting, just between the fact that these white salts and sugars and these really refined kind of carbon molecules that we eat way too much of these days that have this immediate effect really relate to what he's talking about with using these kinds of salts in medicines, and not just throwing away the remains of the plant, but refining it down to one of these salts that will signal to your digestive system, to your mouth, that there is a medicine being taken in that doesn't need to just go down and be burnt up by your stomach acids, but needs to act immediately. And then, you know, imbuing this back with the other constituents of the plant, so the essential oils and the alcohol. So this in practice, I've just got these caraway remains here. They've been soaking in alcohol. I'm gonna just light them on fire and just watch the process of the fire and what's happening here. You know, back to this topic of how carbon, air, and water store matter and information. You'll see right now, it's got all the constituents of caraway seeds in it. You know, it's like, aside from what's been sucked out by the alcohol, this is just ground caraway. And so we've taken some constituents out with the alcohol that are supposed to be taken out with that solvent. And now we're going to burn away other matter that we don't need for, you know, human intake, that were just used for, you know, the plant's reproductive system or the plant's hormonal or defense system. We're going to burn all that away and leave what? Pure carbon. Oop. Haha. Don't want to burn my hand off, so I'm being a bit cautious. And so it's interesting to note, you know, we just take this as a fire and then we get coal, right? But isn't it interesting that all organic matter, whether it be plant or animal or anything, you know, trees, any of it, when it burns down, you just are left with coal. And this is this empty carbon matrix. And that seems like nothing if you think that coal is nothing, but when we find out, you know, its incredible, interesting uses in agriculture, soil science, and in electronics, things like this, this kind of negatively charged principle, or, you know, the way that it acts as one of the polarities, you know, in different kind of field perturbations that we're trying to create, it's a really fascinating product. So the fact that we are burning everything that is no longer needed, that was used for this plant, out of this charcoal, even just as a greater kind of life process, is amazing, that we end up as this empty black coal. So we can see it starting to blacken on the top and even get a little white ash after that, but I'll avoid the white ash for now and I'll give it a stir. And so right now you can see it's a reasonably clean flame, and that's just the alcohol burning out of the seed. So that's going to burn out because it's going to combust at a very low temperature before the actual volatile organics that will combust at a slightly higher temperature will burn up. So I'll just keep stirring. You can see it's still burning very cleanly. There's very little smoke because the alcohol is the first thing to go. It's almost like distillation, you know, where your water isn't going to distill out until the alcohol is distilled out, for the most part, you know, taking, you know, some complexities into account. So it's like the same thing. The alcohol will burn out first. Then we're going to start to see a little bit more gray smoke as the volatile organics start to burn out of this carbon matrix that's holding it, that doesn't combust at such a low temperature. So I'll let it burn up on the top a little bit so we can see this. It may be hard to see on the video, but we're starting to get some gray smoke coming just around the edges where we see this blacken. So obviously the alcohol is wicked out of this little side top layer, and it started to actually burn the volatile organics contained within the carbon matrix. And then as we can start to see a little bit of white ash, we can't see it at the moment, but later on we'll be able to see that really transform into a lot of black smoke when we're getting a lot of white ash, because that's really, the carbon starting to burn up, the larger particles starting to burn up, not having enough energy, not having enough heat to combust immediately. And if you're interested in how things burn and the more chemical explanation of that, Michael Faraday's Chemical Combustion of a Candle is the best read or watch. There's a replication of his old experiments that he performed at the Royal Society, done on YouTube by, I think his name's Engineer Guy, and they're really fantastic. It really explains what's happening as a candle burns, where the combustion's happening, what flame is, what smoke is. But right now we are just starting to see it slowly blacken and burn the volatile organics. So once this is burned down to black, I could choose to just put it out, and that's pretty much how we make biochar, obviously with larger material and with wood. But at that point, I would have charcoal, just empty charcoal, and so I could use it for supercapacitors. I could use it in the soil. I'd have to activate it for certain uses. I could use it for water filtration, so you can see that I can both use it for energy things, for agricultural needs, for filtering water, taking matter out. And, within the electrical applications, there's a lot of nuance to that for what carbon can be used for it, not just for supercapacitors, but for far more advanced applications. So it's a really high use product, and you can see that it's really after we burn out everything that's in it that it's useful. If we just kept, if we tried to use these ground up caraway seeds to make a supercapacitor, it would be useless. It wouldn't act as an energy sink like carbon does. So it's certainly fascinating that we can turn anything organic back into this with fire, burn out anything in it and use it again as an energy sink or as something to filter water. So that's another really interesting one, right? Like nearly every water filter is made, every good one or simple one is made from just chunks of activated carbon, clean carbon that's had everything steamed out of it. And it's so porous, it's when you send cold water through it, it will capture any kind of debris or dirt and actually give you very pure, clean water, to the point where you can put pond water through a good enough carbon filter and you'll have perfectly clean drinking water. And going on that, if you put hot water through carbon, you can actually wash the carbon out again. So it's interesting how temperature plays a role here as well, the energy either in the carbon or in the water. Something really interesting to explore on water memory is the work by Luc Montagnier, a French Nobel Prize winning scientist who kind of had his work suppressed and he was kind of kicked out of his big university and his funding was all cut and he kind of had to go out independent. He's passed away now. But he did some incredible studies on how water is a polar element. I shouldn't say element. It's a polar molecule, a polarized molecule, and it can hold information even after there is no physical matter left in it. So, for example, I believe he was using the AIDS virus, and he was putting the DNA of the AIDS virus in a vial of water. Then he was diluting that water down to the point where the virus should no longer be present. Like there should no longer be any physical matter left in that highly, highly diluted water. And then he was using some kind of process to find out the resonant frequency of the water within his sample flask. Then he was able to transmit that frequency data to another lab on the other side of the world. They were able to use a coil to imbue another sample of water with that same frequency of the AIDS virus and find it present there. So it's incredible how water can hold memory, and this is certainly what the alchemists teach. in Frater Albertus and Robert Allen Bartlett's work, you certainly find that they talk about these same things, that we can still, even after, for example, distilling alcohol out of a tincture solution, we'll still find an imprint of that plant. We'll still find some kind of energetic residue, and it's really Luc Montagnaire's studies that really show us that we can actually scientifically analyze and prove these things. They're not hearsay or the work of, old, outdated scientists. It's actually a new science that we're beginning to re-explore. So looking back to our fire here, you can see it's really started to burn down to a lot of just charcoal now. And we're starting to get a lot more smoke, a lot more embers. See these embers flying up. And of course, these are just energized particles of this carbon flying up that haven't fully burnt up properly. We'll often find that it has burnt up fully by here. But yeah, these beautiful embers are this charcoal in a different state. But we can see more smoke coming out, and I'm sure you probably can't see on the video, but there is some black waves of black smoke starting to come, and that is the charcoal, the carbon starting to rise up and be burnt up. So we'll see this white ash starting to form as more and more of that burns. So obviously, if I wanted to keep my charcoal for some reason or another for an experiment, I would be putting this out very soon. But if you're making biochar, and I'll do another video on that, you do want to make sure you burn everything out. Otherwise you risk poisoning your soil, from what I understand. And same with capacitors. If you're going to use this, you'd want to make sure it is negatively charged, empty, without any of its previous life tainting its new use. So we'll let that burn down a little further. So we can see it's starting to smoke more and more around the edges as more of the matter gains enough energy to start to kind of rise, but not quite enough energy to fully combust. We could see when the fire was full of alcohol that we were getting a lot of flame, immediate combustion. But now that there is less fuel, or less easily burnable fuel, so fuel that combusts at a low temperature, the heat is greater because we've been burning for a while, but we're getting less flame, less combustion. It's just able to kind of send this heavier, denser matter a little way into the air as this thicker smoke before it disperses with the winds. So at this point in alchemy, we'd keep burning this down, and I've found if you leave it for quite a while, it'll go out in a moment. I doubt I'll be able to burn it down to white ash. We'll try. But otherwise, I just leave it to burn down overnight, see what I get in the morning, and then we chuck it in the crucible, in this fellow over here, and just continue to burn it down until we get those white ashes, and then filter it with distilled water through a coffee filter, and then evaporate that water to get the white crystals at the end. And then we even will burn them again if we need to get them more pure, because alchemy really is about finding the quintessence of the plants with that salt, sulfur, and mercury. So one more thing I said I'd touch on the video is how air stores information, and I thought it was just noting, because it really does work similarly to both charcoal and water and anything else that has a polarity and a capacitance. If we look at Nikola Tesla's work and the spark gap, we've got two metal conductors. Look, we could use these tongs. Two metal conductors that would be very, very close to each other at a predetermined distance. And once enough energy builds up from the circuitry or the capacitor behind in our first conductor, and once there is enough energy to bridge, that resistance, that which is, an inherent dielectric capacitance of the air, it will be able to discharge onto the other side of the spark gap. And it's pretty clear from that the air does have its own resistance, its own dielectric capacitance. and works pretty much in the same way as carbon and water do on a more physical level. So our fire's finally gone out, and we're just getting lots of smoke now. See, no flame to burn up or combust all of this kind of denser organic matter or charcoal that's burning out still. So we're just getting lots of white smoke, and then these little glowing pieces that are starting to turn to white ash here. So I'm going to leave that out overnight and just allow it to burn down as much as it can, and then I'll probably do the rest of the process and make that into a tincture in the morning. So thanks for watching and putting up with a bit more of a rambling video, but I just wanted to explore the topics I'm interested in, the things I'm doing at the moment, and for me it's all one giant puzzle that I'm trying to piece together. So being able to see from scratch, you know, how things like the ingredients I'm using in my soil and my capacitors work, and really understanding it on both a chemical and energetic, on a physics level, is very interesting to me. And I want to talk more about the unified physics aspects of it in the future. I guess in a way it's maybe the thing I'm least confident in talking about, because it is such new science where there is really a lot of theory out there, but there's not a lot of practical application. And being a new researcher, it's hard to kind of jump in and be confident to release these things. But I am going to start to do that soon and really show how this relates to field theory, if that's what you're interested in, because it certainly is what I'm interested in. So thank you for watching. Comment and like, subscribe, all of those things. Cheers.